6 things I'll just quickly run it. Architecture principles, I don't have to teach anybody architecture principle, independence, scale, simplicity, resilience. There are 7 tenets for 360-degree architecture. I need experience, operational excellence, performance, analytics, risk, integration, and security. We have 7 research labs. When you go to the design center, each research lab has 40 to 50 research engineers who are continuously working to give you the best support when we are looking for it. When we are giving HSBC as a customer or ENBD as a customer or Bank of Bangkok as a customer, they need this research team which are continuously working on it. A bank cannot invest so much money in research. We can innovate with you, and some of the banks have asked us to say, can our team sit in your research lab? So if they have 10 research members and we have 50 research members, they can coexist in this center. That's the possibilities are there. This is another drawing of an architecture like a building blocks. What we say eMACH.ai, there's a top layer, middle layer, a configuration layer, control layer. So how they have, it's like a building architecture. You have a great building architecture. You have configurator over here. You have a control processor here. You have a system of technology management here. You have a system of exposure is there. These are building block. These are the microservices. So these are the way, if you organize in a clean manner any building blocks, the composability becomes easier. Normally these are sitting in a product. Normal architectures are, one is Finagle architecture, one FlexCube architecture, one architecture from Intellect. So all are sitting in a different puzzle. Yeah, common observability. Turmeric gives a common observability. So this common observability comes with the Turmeric. Turmeric is a common platform which brings a common observability.
So you can ingest all 3 types of various systems and proper.
That's it. Common dashboards. Then this is about the base of eMACH.ai, which revolves around configurability, richness, scalability, integration, and composability. Now this is the way we started looking the cartographic map of the banking. From here the numbering system starts. So when we started our journey for this microservices somewhere in 2011, we start codifying each block of the service so that all the knowledge and the practices and pattern and anti-pattern gets tagged to the specific knowledge packet. So whatever the best practices are there, from saving account to overdraft account to notice deposit, term deposit, each one is numbered over here. So from here the microservices gets created. This we call level 0 knowledge map. So we created a knowledge map which is a level 0 knowledge map. From level 0 knowledge map, it can go to level 1 knowledge map. And from there it can go to knowledge 2 knowledge map. And when you do actual coding, that's at a level 3 knowledge map. But how they are wired from the same nomenclature which makes it wired. So when change happens in one place, you know the change has to transplant to other places. Similarly, this is for corporate banking, these are the various microservices defined. Each microservices is like a cube which you can put it together. This is like APIs which are defined. These are like events which is defined. So once we define all of these building blocks, it's like IKEA table, IKEA furniture. The way IKEA creates efficiency. Now no furniture manufacturer in the world is able to create as much efficiency as IKEA because they have created an algorithm that for furniture making, you need certain legs to support, certain platform to perform on the flat surface. That platform could be 3x3, 3x2, 3x1, but it's a platform. They simplified those blocks, and 3x2 can be used as a table, 3x2 can be used as a lower table. If the legs are lower, it becomes central table. If the legs are higher, it becomes study table, and if legs are higher, then it becomes a standing table. but the block remains 3 by 2 block. They are single platform because it's a repository. So you are consuming and wiring it. So when our chief architect Murli will be talking about turmeric, he will say how we are able to wire them in. Our chief technology officer Krishna will talk about how the wiring is done. But these are all sitting with a nomenclature with the documentation of each microservice is available in Confluence. So it's not documented on a privately structure. It's in Confluence where one can update, and we can copy this for a specific bank, or we can mark the change if it is a universal change. If it's a specific change, we can mark in Confluence that's required for bank A or bank B. This is our even cloud structure has been divided into 5 different layers, C1 to C5 layer, which is a infrastructure layer, going to provisioning layer, to runtime layer, to orchestration management layer, to application development layer. Now, we were very initially when the cloud came and we started the journey in 2016 on the cloud. Both time AI, we set up 2 teams, one for AI team, second is for cloud team, because cloud was coming with so many open sources, and then we got excited with the open sources. We started saying, oh, this is cheap, this is cheap, this is cheap. And within first round, we found 50% of open source was not delivering my performance. And there was nobody to support it, because those organizations which have published those open sources work very well when the first time wiring is done. When we go to the volume of Bank of Bangkok in Thailand, we found they crack. And then each one is, so my technology team really created a mess. They create so much open source libraries, and then we find after 2020 we took a call. It has to be pre-selection criteria for what we want to look at it and what we want to consume for structured manner. And then we need to look at some architecture of this, because we were not even knowing which layer that open source is contributing to. We didn't have a layered architecture of C1 to C5. And what is the alternative tool? They are coming in a random manner. Oh, this will solve this problem, this will solve this problem. So one technology team takes one tool, second product team takes second tool. So by creating this architecture, we could able to see is heuristic model of cloud. I would not say still we reach to the algorithmic level of the cloud the way we reach in other spaces, but we are reached to the heuristic level, because still AWS, Azure, GCP, Oracle keep on bringing their own surprises. So they look similar, but they put their own vocabulary, new model names. Under the bonnet it may be similar, but we need to evaluate them. We look at composability. Is iTurmeric do-it-yourself platform? This platform, we would like to share with you that if this platform has got all the ingredients to be consumed by the bank, so our dependency on the product company can be reduced. You can build your own, configure your own products on using the DIY platform. With the API exchange and a developer sandbox, both are available with real-time debugging. So there will be afternoon sessions on hands-on session on your tablet and notebooks. We have created an environment for you so that you can touch and feel yourself by changing certain things and some configuration, how the end product can be. So from changing one data element in a data design, how that data design can help in mobile to be experience change. So everything is wired in that. This can help in hyper-personalized design, low-touch, no-touch, drag and drop integration. So this, I'm not taking too much amount of time over here. So this is about composite data. So the bank what requires the data, what I'm saying, data is the most, if the same customer data is stored in 10 different tables, my consistency is dropped. So my composite, and the interrelationship of data. Validation is a critical issue in the bank. Most of the testing happens in a product where the validation defects are there because they are interconnected. Banking data elements are interconnected. So we have come out with a new concept called composite data object. Composite data object is a set of 5 or 6 interdependent fields to define as a one composite object. So wherever I am replicating the data object rather than data element, it is inheriting the same properties of a data object. Not the element level. Element level is there, but the validation gaps are only in interrelationship. Most of the defect we observed in last UATs, which we are doing in last 10 years, we used to get it. Bank understanding of UAT interrelationship is different from my BA or my SME understanding of the validation. If I don't define the behavior at that composite object level, data object level, and that data object behave in a presentation layer differently, in an input layer differently, I was leaving the inconsistency there. And every time new change request happen, it further complicate the behavior. So we need to capture the data behavior, data properties at a very, very ground level. So we have a 3 kind of object: data element, data object, and a transaction object. Even transaction object can be defined with the interdependency, that what mandatory fields are there, not there. You can define in data at a one place. Then the second is nested and network shift data model. Today, when you are looking corporate data, there is a nested data. One relationship, one customer would have a multiple accounts, is a nested. But those accounts are, if they have a subsidiary, then it's a network account. It's not a nested account, it's a network account. Now, nested and network account structures are quite complex, and we try to solve this problem by a lot of if-else statements. We put a lot of programs to say, if this happens, this happens, this happens, this happens. And we provide a huge set of if libraries in the system to test it out between network and nested and network. Now, a lot of time we are not given enough thought on nested and network structure. We are going incrementally. When you get a customer like Reliance, or you get a customer like big customer like Indian Oil, they will have multiple subsidiaries, they will have multiple operations, which is nested operation and network operations. So we solve this problem for RBI. Let's say RBI also has the same problem. There's a lot of nested structure and network structure. And third problem of data is data streaming. When there's a large amount of data, we need to use different kind of technology called streaming technology. It's not only the technology which we are habitual of using on API calls. If I want to have mouse over analytics for convenience, means if I take a mouse on a particular field and if I want to see the data on that field, I need a streaming technology. Otherwise, I have to click on that field to get the data on it. Only my mouse over caching technology will be useful over there to do the data streaming. Then I need data as a marketplace. When we say analytics and everything, a lot of time data lake and everything is there, but data is a marketplace. Data is a marketplace for bank employees or bank departments, but data is a marketplace for my customer. Even for Kotak, customer wants to see their own data in a better way. One statement of account is not sufficient for him. He wants to say that if bank is holding the data to me, can I consume that data for myself? Or for some other third-party service provider, he needs the data to be given. So I need to have rules under which I can give it to customer, I can give it to partners, I can give it to somebody else. So data is a marketplace. Then data can create a nudges. Nudges are AI nudges. Based on the data, you can create nudges over there. Now, single data model across experience and operation management. This is about reconciliation, where you need to have one consistent data. So these are the data consistent and contextual. E stands for embedded AI and intelligence. This is what I describe about it, that how the magic invoice, magic submission, magic onboarding, magic ESG, all of it are built into our technology platforms. But tomorrow we'll be discussing about this technologies what we have built. We have delivering a multi-question search kind of a technology, around 150 questions to triangulate the answers for it. So if you want to know a corporate history, it can go to scan multiple databases and triangulate properly. Some demos will be there tomorrow. This is kind of a platform architecture. That first part is my document sources, internal, external, semi-structured and unstructured. I have a formats in Word, Excel, PDF, images, text. All will feed into classification, extraction, normalization, validation, enrichment, verification, and integration. So there are 7 layers of this platform, which is the IDX platform. Then you need a flexibility and extensibility, which is around how do you extend your existing systems. So existing system extensibility, can you create APIs on existing system which can be consumed by Intellect ecosystem. PyTurmeric plays a very critical role in this area. This is the ABCD 6 dimension of eMACH.ai, architecture, base components, base microservices, composability, data, embedded AI, flexible and extensible.